Hello friends, welcome my channel. Today's my channel is Prabal Chakraborty channel, science channel. We are continuously discussing maths, physics, medical science, engineering science. A lot of topics we are discussing. So friend, today's discussion is based on magnetic hydrodynamics. So magnetic hydrodynamics shock waves. My discussions is shock wave. Friends, I am just learner. If you feel that any information is not correct or any information must tell in my comment sections, I will also, if it is a blunder mistakes, then I will also delete my videos and again I will make it I will create another videos for as a learner. This is my target to learn some things. That's why I create these videos and discussions, because only priorities is learning, friends. That's why let's start our discussions. Let a volume V, volume dV be a volume. dV be a volume contained a scalar U, capital U, contain a scalar capital U, then the sum of rate of change of V, capital V, rate of change of capital V, rate of change of capital U, and flux of the vector F into dV, d capital V, F into dV is equal to the contributor is equal to the contributor with contributions equal to the contribution from the source of distribution capital G through at dV per unit, at small dV per unit, then whatever you will say, then del U by del T plus nabla dot capital F equals to G cap. This is the equation 1. So friends, now for a shock front. We know also wave front. Similarly, shock has also a front, shock front. Now for shock front we must take into accent the possibility of discontinuities, the possibility of discontinuity across moving surface. Friends, I have collected this book some note, but I cannot say that where I get these collections, but I have read a lot of various books. That's why I collect one books and make a note, and also I distribute that information I also giving to you. But I don't know that which books I have collected, because a lot of books I created note and from a lot of books. That's why I can't say. But everything is from books, but it is not. It is all everything is my collections. I collected. I see a lot of books and make a note, and that's I discuss in my channels, friends. Okay. But everything is also a book. I collected it from a books. Okay. However, whatever we know that discontinuity across moving surface ST and it's moving with velocity q. Moving with velocity q that bounds a volume capital VT, volume capital VT, in which a differentiable scalar functions is defined I is defined. Okay, it is a VT is a scalar functions. It is defined. Okay, and a scalar function in which a differentiable scalar functions means this scalar function means T. It is domain is T, and now let capital I equals to integration under the volume is capital V, T, and U into dV. This is the capital I, and in time increment del T, in time increment in time increment capital small del T is time increment. The integrand at capital I becomes capital U plus del U by del T into del T. Del T. So friends, this is the total fact I discuss. Another fact is but. We can say but in this time, but in this time volume bounded by rho t and changes since ut not volume bounded by rho t and vt is the volume and v2 vt changes vt change. And friends, let vector surface element ds let vector surface element d capital S of del T capital of del T moves a distance q del T in this q del T in time del T in time del T, and so corresponding element of volume change q d rho and del T, q d rho into del T, and then the corresponding increment in the corresponding increment in the integrand its capital U q del rho del T. corresponding increment in the integrand, it's u q del rho into del t. So friends, whatever we say, that we know that I is equal to, in case of Vt, we see that I, capital I, and plus del t. Whatever we see that it is integrations with respect to I discuss in here. You will see that u plus del u by del t, u plus del u by del t, this is the increment. So I plus, and that's why it is Vt, is under the Vt. Then we see that u, capital U, plus capital del u by del t by del u by del t into del t, and after that dv, plus increment. I also discuss that whatever I discuss that increment in u plus del rho into del t. So it should be in here. I have to putting this in here. So whatever we see that, plus, according to the plus st capital U, and it should be 1 minute, it should be ds. It is ds u q into d, capital S, into del t. So friends, this is the total factor. So in actually, whatever we know, I also I discuss that I is, this value is I, this value is I. So whatever I will get when we see that I added this. So my del I, it is not del t. Del I should be another fact, that del I equals to whatever I will get some different integrations integration Vt del u by del t into del t into dv, plus integration st, capital S, comma t, integration capital S, comma t, is equal to u capital U dq into d, capital S, u dq, not uq ds into dt. This is the total fact. So friends, whatever another fact, that del I by del t, that's why I get del I by del t equals to integrations capital Vt del u del t into dv plus capital U capital S, comma t, u into q into d, capital S. This is the total formula, friends. And after that, whatever if we del t, suppose del t tends to del 2 tends to 0, then whatever we get, that implies di by dt, d capital I divided by dt, we get di by dt value is our integration capital Vt and del u by del t into dv, d capital V, plus I apply Gauss's divergence theorem, friends. Here it is the surface integral is converted into volume integral. So volume integral, whatever I get volume integral, I just translated it. So it should be changed. It should be this way: del capital U Q, del capital U Q into capital D V. So friends, whatever we see, we learn this way, and I just apply Gauss's divergence theorems. So friends, whatever I get d capital I into d into small t equals to, I get integrations capital Vt, and just putting in here, I get del u by del t, plus I get u into q into uq dv. So friends, we know this value, that del v by del t values. So del u by del t values I discuss in the first step, that you know that del u by del t value is these equations. Del u by del t is these equations. Del u by del t plus del nabla dot f is equal to g. G is the source of distributions. What is G? Is the source of distributions dv per unit volumes. So I just putting the del u by del t value, this value from these equations. Which equations? These equations, friends. Equation number 1. So from equation number 1, from equation 1, whatever I get d capital I into dt, I get integration Vt, and I just putting the value whatever I get capital G and capital G bar minus del capital U small q, capital A U small q, and plus, sorry, not plus, it is minus, it is plus, it is plus, and it is minus whatever I get same things, minus del f, friends. So this is my total value. I just generalize this value from 1, and after that whatever I get assuming that assuming u or g have any singularities. Now u or g doesn't have any singularities, I assume. Okay, and after that whatever I get and Vt, I write down in here Vt and del capital UQ minus capital F, del UQ minus capital F into D capital D into dv plus small g, sorry, small g, and whatever I get another factor. It is small g also dv, d capital V. This is the total values. So after that, whatever I get integrations capital V small t, capital V small t, and after whatever I get g and dv. It should be, and it and this portion I will just transform into I apply also Gauss's divergence volume integral. I convert it into surface integral. So friends, I write it this way: integrations st means under the surface, capital uq minus capital F into ds. So friends, whatever we say, the discontinuity of the surface, assuming I write assuming neither u or capital G have any singularities, So friends, this is the singularities. And now suppose a discontinuity of surface each an arbitrary part and an arbitrary part a star is a star, arbitrary constant a star, comma a star t, and lambda it divides the volume. It divides the volume V0t the lambda, this values is divided V0t and V1t, capital V1t, and the surface so the S1t V1t. So from 3 we get another value is integration capital S star capital S star comma t uq, this is the initial, capital U Q minus capital F 0 d s comma is 0 plus plus integration same uq minus f0 comma a star comma t uq capital U q minus f1 d capital S 1 and d, where the d is 1, and after that whatever equals to d is 1. D is 1 equals to 0. So friends, whatever another factor that in here d capital S is in here, whatever we see in here, we see that in here we see that d star comma 0 d star comma 1 is the outward directed vector surface outward directed vector surface element outward direct element of a star t and with respect to wrt with respect to v0 t with respect to v0 t but d capital S 0 d capital S 0 equals to d capital S 0 star. So outward directed vector surface ds1 outward, and it is the ds rf naught is inward directions. So it is minus d capital S1 1 star minus equals to n capital n directions is n cap d capital S using d capital S star. This is the total formulas. And another factor that when n is outward down normal, n cap is outward, n cap is n cap equals to the outward drawn normal outward drawn normal So friends, it is we get the one equations uq minus f0. So whatever we see that integration, we see that uq minus capital F, and it is the 0 mine n cap minus uq minus capital F 1 n cap equals to 0. So friends, this is I get. So this is a jump discontinuity. We get a jump if we denote denote the jump if we denote jump by capital X1 minus capital X0 is equal to box of a capital X. Then whatever we get, I get that UQ is then I get lambda bar capital U minus f dot n equals to 0, and after that whatever we get lambda bar equals to q bar n bar. This is the total factors, friends, and it's the normal speed is propagations is discontinuity surface. So G can be written as which done the discontinuity. So if the normal speed of propagation the discontinuity surface. So friends, whatever we see that if capital G bar means our this is the disturbance can be if G can be written as capital del capital G which alone discontinuous at a star, capital S star, and then we get as before, we get as before third brackets lambda bar U, capital U, lambda bar capital U minus f n into U, and this is the total plus capital G, capital U and n star n, this is the equals to 0. So friends, this is my total equations of the magnetic shock waves a given distributions. Now we discuss the Rankine. Our discussions is going on Rankine. Hugoniot, Rankine Hugoniot relations, generalizations of the short magnetic wave, generalization of waves, shock waves. So friends, before these relations, you have to know that the equation of the general equation of the equation in the form general equations. You have to know the general. Let us rewrite the energy equation. Let us write the energy equation in the form. Energy equation in the form half m capital small, it is the discontinuity, it is the discuss though, so it is represent the third bracket, capital v square plus m e plus m divided by 2 mu e, m divided by 2 mu e into tau capital B square and plus Vn P capital P plus 1 by 2 mu e plus Vn B square minus capital Bn. Here Bn is all our magnetic field, friends. Bn is a magnetic field, and mu e and small third bracket Vb. So friends, this is the total equations of the energies, and after that next equations, that where tau equals to 1 by rho, where tau is equal to 1 by rho, and is the specific volume of the fluid specific volume of the fluid, but capital R is equal to Cp minus Cv, and capital minus Cp minus Cv, and the adiabatic exponent, adiabatic exponent, but the adiabatic exponent gamma is equal to Cp by Cv, capital Cp by capital Cv, capital Cp by Cv, while for a polytropic, while for a polytropic gas. Polytropic gas means PV to the power n equals to constant. This is the polytropic gas. For a polytropic gas, CV into T. CV, C capital V into capital T, E is equal to CV into T. And where, and therefore we can write, the equation, we can write the equation gamma equals to, not gamma, capital small e equals to p tau, because the gamma formula I just putting capital P and small tau, tau means in here, where is tau, tau, p tau and gamma minus 1, p tau into gamma minus 1. So friends, this is the equations I get, and I just put this value, equation of energy. Whatever is my energy, this is my energy, this is my energy equations. This equations is called energy so my energy equations is this. My energy equation is this. This is my energy equations. I putting the value, whatever I get, E values, it's tau values. So I just putting that E value in here. So whatever I get, energy equations 1 becomes, number 1, half, 1/2 half into m v square, m v square plus m divided by gamma minus 1 and p tau plus m divided by 2 mu e, m divided by 2 mu e in tau, tau capital B square. This is my equations. Tau B square plus V P plus 1 by 2 mu e, 1 by 2 mu e Vn capital B square, plus Vn mu e minus Bn mu e. This question is coming from a lot of university, Hugoniot generalizations. Here I discuss both two proportions. One is shock wave and another is generalizations. I discuss two. Bn mu into capital Vn and capital B. Vn capital B equals to 0. Now I use the mid values property. What is the I use this value, capital V equals to this property. I use V equals to half of V0 plus V1. this property I use in here. So according to the, if I use this property in the energy equations, whatever I get m divided by gamma minus 1 p tau plus vnp minus p vn small vn and plus m divided by mu e tau b square plus 1 by 2 mu e vnb 2 mu e divided by vnb tau b square bn okay, m divided by tau b square 1 by 2 and vnb square minus capital bn n mu e v capital into capital b both are vectors, so I just giving vectors dimensions b so plus 1 by 2 mu e 1 by 2 mu e capital B square and Vn plus Bn n by mu e Bn by mu e plus capital B into small capital B by mu e capital V this. So this is my total. I explained this way, and here I discussed the speed lambda bar of the discontinuity, the speed continuity surface must be continuous discontinuity surface continuous across the discontinuity and therefore it follows equation this equations it follows V V N N equals to Vn. So friends, whatever we get, that is m tau equals to Vn. M tau equals to Vn, and apply the identities. Applying the identity. Apply the identity box PQ, capital P, capital Q. This is the identity. Applying the box PQ is equal to capital P, Q plus small q plus box P. This is the identity. This identity I use, and whatever I get the energy equations, my energy equations should be changed, and I also apply this I using this equation, this property and this property in here in my energy equations. So my energy equation should be m divide by gamma minus 1 small p tau, small p tau plus mp and tau, mp and tau plus m by mu e into tau b square, plus 1 by 2 mu e, Vn capital B square, friends. And after that minus whatever I get, minus capital Bn and mu e and integration boxed v and b minus 1 by 2 mu e capital B square and Vn plus Bn divided by mu e capital B and V equals to 0. So friends, this is this value I get, and another property using property. Which property we use? Let's see. Property. At first I write. What is the property? Property is capital P square p square minus blocks capital P whole square equivalent to 1 by 4 box capital P. So my the energy equation should be m tau box capital B P plus m box tau box tau capital B whole square equals to capital BN capital V small v bracket B. So friends, and another factor that whatever we get next equations from 8, next equation we just using that 1 by gamma minus 1 and p small tau plus I just apply these equations we using the property. Friends, this is the two property I use, this property and this property I just used, and I get the equation p tau plus small p box tau plus 1 by one by 2 mu e tau 2 mu e tau and capital B square capital B whole square equals to 0 and that is small e plus capital U and tau equals to minus 1 by 2 mu e and tau and B whole square. This is the generalizations. This equations is the side of generalizations of the Hugoniot generalization. So these equations this is equation 2 equation capital tau. This equation is capital I, this equation, and this equation is called generalizations of heat equations. Generalization of Rankine Hugoniot relations. So thank you friends for watching. Today's class is very long discussions because this chapter covers total astronomical physics and a lot of very important for physics. So friends, thank you for watching.